DSPy employs a meta-optimization strategy through the BootstrapFewShotWithRandomSearch, Teleprompter, which synthesizes high-quality few-shot demonstrations and performs a stochastic search over candidate programs to maximize a user-defined metric. This approach combines self-generated examples with random exploration to systematically improve program performance without requiring extensive labeled data. We are about to examine how this optimizer is configured with specific parameters for bootstrapped and labeled demonstrations, and how it compiles a given program against a training set to produce an optimized version. The configuration will specify the number of candidate programs to evaluate and the balance between generated and pre-existing examples, while the compilation process will leverage these settings to refine the program's prompts and behavior. From DSPy, teleprompt import BootstrapFewShotWithRandomSearch. Hash set up the optimizer. We want to bootstrap, i.e., self-generate 8-shot examples of your program steps. Hash the optimizer will repeat this 10 times plus some initial attempts before selecting its best attempt on the dev set. Config equals dictmax bootstrap demos equals 4. Max labeled demos equals 4. Num candidate programs equals 10. Num threads equals 4. Teleprompter equals bootstrap few shot with random search metric equals your metric here. Asterisk config. Optimized program equals teleprompter compile your program here. Train set equals your train set here. This code demonstrates the BootstrapFewShotWithRandomSearch optimizer, which combines few-shot learning with random search to optimize DSPy programs. The optimizer generates multiple candidate programs by bootstrapping demonstrations and evaluating them against a metric, selecting the best performer. The configuration specifies generating up to 4 bootstrapped examples and 4 labeled examples, with 10 candidate programs evaluated in parallel across 4 threads. The approach leverages self-generated examples to improve program performance without requiring extensive labeled data. By running multiple iterations with randomized example sets, it explores the solution space more thoroughly than basic bootstrapping. This is particularly useful when you have moderate amounts of training, data 50+ examples, and want to balance exploration with computational efficiency. The trade-off here is computational cost versus potential performance gains. More candidate programs, num candidate programs equals 10, increase the chance of finding better solutions, but require more inference calls. The parallel execution, num threads equals 4, helps mitigate this cost. This optimizer sits between simpler approaches like BootstrapFewShot and more complex ones like MIPROV2, offering a practical middle ground for many applications. Let's break it down. From DSPy, teleprompt import BootstrapFewShotWithRandomSearch. Imports the BootstrapFewShotWithRandomSearch optimizer class from DSPy's teleprompt module, which enables few-shot learning with random search over generated demonstrations to optimize DSPy programs. Config equals dictmax bootstrap demos equals 4. Max labeled demos equals 4. Num candidate programs equals 10. Num threads equals 4. Creates a configuration dictionary with 4 key value pairs. Max bootstrap demos set to 4. Max labeled demos set to 4. Num candidate programs set to 10. And num threads set to 4. This dictionary likely configures parameters for a DSPy optimizer, specifying limits on demonstration counts, program candidates, and parallel execution threads. Teleprompter equals bootstrap few shot with random search metric equals your metric here. Asterisk config. Creates a teleprompter instance using BootstrapFewShotWithRandomSearch, configured with a custom metric and additional settings from the config dictionary. This optimizer will perform random search over multiple candidate programs to find the best configuration based on the specified metric. Optimized program equals teleprompter compile your program here. Train set equals your train set here. calls the compile method on a teleprompter object, passing your program here as the program to optimize and your TRAINSET here as the training dataset. This initiates the optimization process, which will tune the program's prompts or weights using the provided training data to improve performance according to the defined metric. The result is stored in the variable optimized program. The BootstrapFewShotWithRandomSearch optimizer in DSPy combines self-generated examples with random exploration to systematically improve program performance. By configuring parameters like max bootstrap demos and max labeled DMOS, you balance between generated and pre-existing examples, while num candidate programs and num threads control the search intensity and parallelism. This approach leverages few-shot learning with random search to explore the solution space more thoroughly than basic bootstrapping, making it practical for moderate datasets. The trade-off between computational cost and performance gains is managed through parallel execution, offering a middle ground between simpler and more complex optimizers. The optimizer's strength lies in its ability to refine prompts and behavior by evaluating multiple candidate programs against a user-defined metric, ultimately selecting the best performer for the given task.
The compiler bootstraps silence into DMOS. Now, the fastest program is the one that never writes a line of code.